All right, so in this particular video, we're going to look at how to solve logarithmic equations. To solve them, essentially what we want to do is we want to write both sides of the equation with a single term. Once you've done that, you can do one of two things. You can either equate logarithms to each other, the bits inside, that assumes they have the same base, or you can use the exponential form to solve. We're going to do both methods at some stage here, so you'll see how we go about this. So let's do our first example. We've got log base 10 of 3x plus 4 equals 1. When I have something like this, I've got a single number on the right-hand side and logarithm on the left-hand side. I need to think of our whole conversion between logarithms and exponentials. If I have logarithm of base a of y, that can be written as an exponential instead, where a is the base, x is the power of the exponential, and y is the result. So this thing over here can become the bit inside, the 3x plus 4 gets written by itself, equals the base 10 to the power of this thing on the other side of 1. And then I solve this. So 3x plus 4 equals 10. Well, that just becomes 3x equals 6 and x equals 2. Nice and simple when you have one term each side and you write with your exponentials. This next one, same thing. I've got a single number on the right-hand side. So first step I'm going to do though is divide by 2. 8 divided by 2 gives you 4. And at this point, we have a single term, there's no number in front of the log, because that's really important to get rid of this 2 first. Because notice the rule over here has nothing in front of the log. Now I can do the same thing. So the 5 minus 3x stays as is. It's now 2 to the power of 4. Please don't mix that up, that order up. In this particular example, it won't matter because 4 squared is the same as 2 to the power of 4, but it is not going to work 99 times out of 100, if not more. All right, so we subtract 5. 2 to the 4 is 16. Take away 5, and that gives you 11, and divide by the negative 3. All right, let's keep going. All right, these next two are actually the same idea, but this time the unknown is in the base, isn't it? So in this case, we're still going to do the same thing. We're still going to have the 27 stays by itself. X, the base here, x, the power of 3. And once you have that, this drops back down to what we've been doing with exponentials as well. We have 27 written as 3 cubed, and we have x cubed over on the right-hand side, which means x must be 3. The other way, of course, if you have x cubed equals 27, you just find the cube root of 27, which we know is 3. So both of those methods from this point will be fine. It's just getting rid of that log. Same thing over here. 64 is the result when I take 2x plus 1 and I square it. So again, I can write 64 as 8 squared if I want to, or I can take square root of both sides, which I'm going to do this time. So 2x plus 1 equals plus or minus 8. Then we're going to simplify it. 2x equals, or 8, negative 8 minus 1 is negative 9. Positive 8 plus and minus 1 is 7. And divide by 2, we get this. Now, before you go, yes, we're finished and move on, we're about to, you need to remember that the base, this base here, must always be positive. Must have a positive base. So let's look at this. Negative 9 over 2, if I put negative 9 over 2 into that base, you end up with negative 9 plus 1, which is negative 8. Yeah, but x greater than 0, therefore x must be 7 over 2. So we cannot have negative 9 over 2 because you have a negative base, which we don't deal with for logs. All right, now we're going to move on to the next 3, which require a little bit more work. In fact, looking at them, they all drop out to being like the examples we've got there, but we can edit them a little bit as we go, or show an alternative way to show the other one I was talking about. So something like this, my first step, I've got 2 logarithms, I want 1. I want one logarithm on the left-hand side, so one term each. So what I want to do is use my log laws. Now this one, we got a plus between them. So we got to think way back to log laws in definitely year 11, potentially year 10, maths depending on class. Get the same base, so you can multiply the bits inside the logarithm. So this means we have log base 3, they both got a base of 3, of x bracket x plus 8 like this equals 2. Now at this point, I can do what I was doing before. I'm going over here, I can do, oh, well, x bracket x plus 8 equals 3 squared, which is 9. And then I'm solving a quadratic equation, which I know how to do. Okay, x squared plus 8x minus 9 equals 0. X plus 9, x take 1 equals 0. X equals 1 and negative 9. But then again, I have to check here. Remember, inside a logarithm must be positive. So you know x has to be greater than 0. Therefore, x can only be one of those two options. Okay, but the other way I could do this one from this point is I could, and I think this is probably the easiest way, but you could also write the right-hand side in terms of a log. All right, so I could write 2 as log base 3 of 9, because we know that 3 to the power of 2 gives you 9. And remember, this is the power that gives you 9. So you get a value of 2 there. And then at this point, you can see a logarithm is the same on both sides. X bracket x plus 8 equals 9. And then you proceed exactly the same from that point onwards, because we have a quadratic. It's the same one for both. Let's do the next option. All right, the one thing you should notice about here, you got a 2 at the front. That's important. You must remove that first, and you got a minus. So the two things here, when you've got two bases, two logs with the same base, and you have a minus in between them, you need to divide the bits inside the logarithm. That's important for us. And the other one that's going to be important now is this one. You have, doesn't matter what the base is, you can bring that power into the base and write it up there. So we're going to have to use this one. This one comes first, this one comes second. You kind of treat it like BODMAS. This 2 at the front is kind of the power. And also it's multiplying. So we're going to deal with that first. So we got log base 3 of 5 squared, which we know is 25, minus log base 3 of 2, plus log base 3 of x. Don't get sucked into combining these two by multiplying them first, like we did before. It's not correct, because this negative is attached to that 2. Okay, so don't combine those two first. Do the 2 first at the front. Do this one. And now we're going to go left to right using our laws. So these two together have a minus. So you divide the bits inside. So that gives you log base 3 of 25 over 2 plus log base 3 of x equals 2. That plus means we're going to combine them inside by multiplying 25 on 2 and x. And then we're going to go back to the same we've done before a number of times. We now write it as 25x over 2 equals 3 squared, which we know is 9. And then we're going to multiply by 2, which gives you 18, divide by 25, gives you 18 over 25. A final example. This one I've introduced the base of e because we're not going to get a nice whole number every single time. Your answer is going to be an exact answer with e. Remember, e is Euler's number. And that is approximately 2.718, You don't need to know exactly what it is in terms of to 20 decimal places, but having an idea it's just less than 3 is really important when you're trying to work out where it is on an axis. But just because we have Euler's number for a base doesn't mean we do it any differently. It works the same. So same base, the plus between two things, we multiply them We got log e of 2 bracket 3x plus 5. You could actually write ln instead of log base e. That's just habit that I have of log base e. And then we have 2 bracket 3x plus 5, and we use our conversion to index form is e squared. That one we can't simplify any further because we don't have a whole number for that. So we divide by 2 equals 1/2 e squared. We subtract 5, and then we divide by 3, like that, minus 5/3. And that is how we solve logarithms or logarithmic equations.